This video is a quick reminder of vertical motion and how to use the graphing calculator to find the x-intercepts and the vertex of a parabola or any point along the graph. So as a reminder, up at the top of the screen you see your vertical motion formula. Remember that v sub 0 is your initial vertical velocity. It's measured in feet per second. If you throw something up in the air, the number is positive. If you throw it down, it's negative. If you're just dropping it from the top of a building, it would be 0. H sub 0 is the initial height in feet from where you're dropping the ball or throwing something upward. It's where it begins. Okay. Remember in your possession, I gave you this nice image here, quadratic keywords, where if you're looking for something like how high off the ground did the object start, you know then that's a question of the y-intercept. So if you're unsure of what you're looking for, this resource could be really helpful. Let's do an actual example together here. A ball is thrown straight up from the top of a 328-foot tall building with an initial speed of 32 feet per second. So all I did was I substituted, plugged in 32 for v sub 0, and I plugged in positive 328 for how high up it initially started. So down here in the right corner, I sketched an image of the path the ball would take over time. So it goes straight up, gravity takes over and causes it to accelerate more quickly towards the ground. The first question is, how long will it take for the ball to hit the ground? So that's right here when it's hitting. And what part of a parabola is that? That's your x-intercept. So to find it, we could certainly do the quadratic formula, plug in 0 for h of t, but instead we're going to use the graphing calculator for sake of time. So in order to use it, you hit y equals to input your function. We're not going to use t, we're going to use x. So type in negative 16, x is next to the green alpha key, squared, plus 32x plus 328. Now, if I glance at my window, remember depending where you're looking out the window, you're going to see different things. Reminder that an x controls how far left to right you see. So I see negative 10 to the left of 0 to positive 10. Y controls up and down. So I'm seeing 10 units below ground and 10 units above ground. If I hit graph right now, I'm not going to see very much of the parabola. It's almost going to look like two lines. Because remember that the ball is thrown 328 feet up in the air when it starts, and I'm only seeing up to positive 10. So I need to see much higher. So I'm going to leave the x alone because I was able to see where it was hitting the ground. But I'm going to scroll down using my down arrow, and I'm going to change my minimum value. I'm going to make that be negative 50 just because I want to see a little further below ground. And I'm going to change my maximum. Well, if the ball leaves 328 and goes up higher, I'm going to see all the way up to, let's say, 400. I don't know if it'll reach that high. I'm just guessing. I might have to change that number again. So I hit graph, and you can see my parabola. I can see a little bit above the parabola and a little bit below ground. So the first thing I'm going to do is find the x-intercept. To do that, you always hit second trace to see your different options. The zeros, option 2, are used to find the intercepts. The calculator will ask you 3 questions: left bound, right bound, guess. The left bound, you've got to move the cursor really close to where it crosses the x-axis. So moving it to the right, but it has to be to the left of where it crosses the x-axis. So I want to get it really close. And if you look at my y value here, I can see that it's 4.54, so I know that I'm still above the x-axis. So I'm going to hit enter because that's bounding it on the left. Now the right bound, I'm going to move my cursor further to the right. You can see my y just dropped to negative, so I know I'm below the x-axis, so I hit enter. And now the calculator is asking me, should I guess? Yes, so hit enter. And right here, this is the place at which it's hitting 0, 5.636892, 0. So I am going to just change colors here. I'm going to write this in seconds. If I'm asking how long will it take, I'm going to round to the nearest hundredth. Please make sure you round correctly for me. So it would be 5.64 seconds. And that's approximately, so I'll say about 5.64 seconds. Now, the next question is when will the ball be at its maximum height? Well, if I look at my sketch, that's happening up here. If you think about it, that's going to be the vertex of the parabola. So to find the vertex, what I'm going to do is hit second trace again. If you look at your options, I'm really wanting to know when is it at its maximum point, so that's option 4. It's going to ask me the same 3 questions. Left bound, right bound, guess. So that means you move your cursor to the left of where the vertex is. Not too far to the left, but make sure it is to the left of it. Hit enter. Now it says right bound. Move my cursor a bit to the right. Hit enter. And now it says guess. Yes, please guess. And there it is. It looks like it's about 1,344. This says, when will the ball be at its maximum height? Well, remember that time is the x and height is the y value based on the way our function's written. So when does it occur? That's the x value at 1 second because it's measured in seconds. 1 second. Part C, I already have the information on the calculator screen. What is the height? Well, at 1 second, it's 344 feet in the air. The last question, part D, how high up will the ball be after 5 seconds? That's just going to be some point along the graph. If I just move the cursor to the left and the right, we're seeing as time progresses how high the ball is. Oops, I have to hit trace to see that. Hit trace, and I move left to right, and I see it's traveling along the parabola. If I want to know at exactly 5, it's very easy. After I hit trace, all I do is on the keyboard hit 5, enter, and there it is. At 5 seconds, the ball will be 88 feet in the air. Okay. So there's a sample of how to use the graphing calculator with the vertical motion problem. I hope this helps you. If you're still struggling with adjusting the window, play with a few different parabolas till you get better at it. See me for help if you still need additional assistance.